Hi everyone, good afternoon, and welcome to the webinar session on demystifying generative AI and RPA. We are talking about the applications and benefits for your business. I am Anjan Kulkarni, Business Development Manager at ESSPL. Generative AI and RPA are two distinct but complementary technologies that can be powerful tool for your businesses. In today's session, we from ESSPL will be demystifying each of them and explore their applications and benefits. I have Mr. Ritam Chakravarti, Head of Products and Solutions, ESSPL, as the main speaker, and Mr. Saroj Pradhan, AVP Product Engineering Capability, ESSPL, as anchor for today's session. So over, you can go ahead with the session.
Hi, good afternoon. This is Saroj. Thank you all for joining this call. In this webinar, as Anjan pointed out, we are going to discuss generative AI and robotic process automation. As you understand, technology-wise, both are evolving very rapidly. So using these technology, our customers are trying to solve various business problems by leveraging the AI around content generation, chatbot, image processing, and natural language understanding, etc. In the next couple of sessions, we are going to focus on how GenAI and standard AI built into RPA are different, and at the same time, how they can work together to create more powerful, intelligent automation solution to solve specific business use cases. With that, I would like to invite Ritam. Ritam, can you throw some light on how do you see the technical evolution happening around and how it is heading towards the future?
Okay. So first of all, good afternoon to everyone, and thank you for taking your time out and joining this session. So Saroj, the question that you asked. So in my opinion, before we start understanding the technology evolution, we have to take a step back and look at human evolution. And if you look at human beings as a person, as a being, you will see we have a lot of abilities, but bearing one, we are best in none, right? Like we can move, but we are not the fastest. We have strength, but we are not the strongest. We can see things, but our eyesight is not as strong as those nocturnal animals who can see through nights. We can hear, but our hearing capability is only within a restricted band of frequencies. We cannot communicate long distances as few of the animals can do, right? But the place where we excel and we set us apart from all others is our ability to think and able to learn from these things around and adapt to changes. That's what sets us apart from all others. But if you look at the overall thing as a one place, then human beings are made with constrained abilities. Now, what they have to do was, from the very beginning, they had to do something to increase or enhance their abilities so that they could remain relevant in the scheme of things of nature, be it the urge to live on, be it the urge to climb up the food chain to remain in existence. They had to do something. So the reliance on augmented abilities was not a thing of luxury for human beings, but it was a thing of necessity from the very beginning. And to achieve augmented abilities, they had to do something to achieve that, and that is the human ingenuity. And I call that human ingenuity by which they could create augmented or enhanced abilities as technology, right? Now, throughout the human history, if you now look at, every time, everywhere, we have been using technology to create enhanced abilities. So it can be right from the beginning when we light the fire first time, to the invention of will, to the creation of small tools which could help us in doing more work with less effort. And coming to the modern times, we are sending Chandrayans to explore alien worlds, right? All this while, whatever we are doing, the technology is evolving to give us those augmented abilities by which we can sustain. Now, Now, this has been the trend in the technology, but now the question is where we are heading towards. The question we talked about, where we are heading towards. Now, so far, most of our focus, right, till late mid 90s, and our focus have been more towards improving our physical abilities. We could move fast as quickly as possible. We could talk to people across the world in split of a second. We could peep right inside the cells and bacteria, and we can look at the microscopic world. We could look into deep space and try to understand where is the life beyond Earth. But all these are mainly and largely has been towards improving our physical abilities. Now, from mid 70s to mid 80s, then the revolution started coming where people started looking into improving the mental abilities, and computers were the first thing of interest, which actually enhanced a big jump, it helped us in attaining a big jump there. But now, as the things progresses now, we are moving to the next order of human intelligence, and that is where we are going towards bionic intelligence. Like we are trying to create technology which can enhance our abilities to think, enhance our abilities to process data, interpret, and take decisions which a normal human being may not be able to do all by himself. So if I look at the technology where it is directing towards, it is not evolving towards helping us get bionic intelligence, which could enhance our ability of thinking. Now, two factors that I can see is actually also assisting this revolution. One is accessibility, and number two is affordability to resources. Right. Now, if you look at bionic intelligence, like or artificial intelligence in a normal term, we require a lot of data to be processed, right, to make this science work. Now, to do that, we need, number one, a large amount of in-memory processing capability. Number two, a lot of computational power, we could process large things in less amount of time. And we should have a large storage capacity where we can store these data. So if you now look back in like 2 decades back, hardly a handful of people could come across or create that kind of resource and get access to that kind of resources. So the pace of development was very slow in the last 2 decades. But now if you look at with the coming of internet, which is virtually giving us access to almost infinite, theoretically infinite resources, and the drastic reduction in the cost of accessing mobile internet. Right. I was looking at the other day. In India, the cost of accessing 1 GB of data is just 13.98 rupees. It's just as equal to buying one rasgulla. It is as cheap as that. So now a much bigger mass of people can now contribute towards the advancement of this technology, the bionic intelligence. So the pace of technology evolution now has gone 10 times faster than what it used to happen 2 decades back. So that's one of the criteria that I'm seeing that bionic intelligence is moving towards, and that is the direction the people are taking. But if I come back to the technology level, now scientists have found out that, okay, in order to attain this intelligence, we have to mimic the human ability of learning and adapting their process. So typically, humans adapt or learn by following 4 steps: act, fail, learn, adapt. Right. Like if I take an example of a toddler, the first time he starts standing up and try to walk, he will definitely fail. Now, over the period of time, he will learn that how to put the steps forward, how to balance the other parts of the body to attain the balance, and probably make adaptations in his posture, make the right moves, and probably he will again try to walk. And after some iterations, he will probably succeed. Now, this process of act, fail, learn, and adapt is the essence of how we have been learning in any field we go in. So the bionic intelligence is also now mimicking this activity: act, fail, learn, and adapt. Now, to me, actually, I can segregate these 4 areas into 2 technology verticals. Right. The first one, if you look at the act, it's all about doing things. And that is where the automation technologies in the IT terms, it comes into play, which helps us to do things which can help us to take actions. So automation technology is one vertical where the actions come in. And their robotic process automation is one of the leading platforms which are helping us in automating anything which is rule-based, repetitive, and beyond the boundary of a system. It can work across systems, automating things. Now, the other three elements, fail, learn, and adapt, falls under the category of artificial intelligence vertical, which helps us in learning, adapting, and taking decisions in an iterative manner to create the higher order intelligence. So now, if I look into the future, the automation and the intelligence are kind of converging into something that we are now looking and talking about, intelligent automation. So something which is shifting from codified rule-based automation to intelligence-based automation. That is where the intelligent automation is going towards, and that is the progressive evolution of technologies that we're looking at. Now, from a programming point of view, if I look at, to do these kind of intelligent automation solutions, we need access to technologies, both in the two verticals, which can be integrated seamlessly and be used. And for that, the technology stack that is evolving is already in our hands. Like in the RPA segment, you have enterprise-grade platforms like Automation Anywhere, UiPath, Power Automate, then your Open RPA in the open source world. So there's a bunch of technologies available which are helping us do in the automation side. While on the artificial intelligence side, there are a lot of technologies which is now evolving because of the democratization of the artificial intelligence thing, where things like TensorFlow or PyTorch, or even the cloud services like Azure AI Builder, Azure Form Recognizer, and all that, which is helping even the citizen developers to come and contribute and create solutions. So going forward, what I see, the space is moving towards intelligent automation. The technology evolution has always been towards augmenting our abilities, and the technology stack that we're looking at is converging and kind of creating a confluence of both automation and artificial intelligence stack. So Saroj, this is what I think about the evolution of technology so far.
Okay. Yeah, that is very insightful. Pritam, can you describe what is intelligent automation and how it is different from traditional automation?
Right, it's a very good question. But before I explain you what is intelligent automation, let me first quickly describe why at all we should go for intelligent automation. Because it's not that it's a geeky thing. We all love to play with technology, so we should use it. Or somebody told me that's why I'm going to use it. No, there is a definite business case now evolving, which is actually pushing us towards adoption of smarter technologies. As is said that necessity drives the change. Now, current market, if you look at, the demand forces are pushing companies to adopt smarter technologies. And when I say demand forces, it is the end users who are making the calls. Because now the customers or the end users, the people, are exposed to everything. We want minutest control of anything that is happening. We want to get real-time visibility of where is my shipment now at this moment. I want to control the shipment and participate in decision making, saying where I should get this shipment, when I should get this shipment, I should be able to change, right? So the industry, the driving force, the demand force, which is coming from the end users, they are looking towards higher order intelligence. They are looking towards technology where they can produce less inputs, and the system should produce higher intelligence. Less input, but higher intelligence. Now, if you look into the supply side, which is the companies who are providing these services, like, for example, in the supply chain domain, the companies who are providing shipment services, the freight forwarders, the 2PLs, now they are facing a different range of problems. They are finding that the business outlook is not so hunky-dory now. It's a little gloomy. The industry is going through the consolidation cycle. So many of the companies are downsizing, or they are putting in fiscal restraints to remain profitable. But on the other hand, the demand forces are sky-rising, as I have just mentioned. So when we are talking to the CTOs of those companies, they are saying that, yes, we are ready to adopt technologies, but those technologies needs to give me operational excellence. It needs to give me optimization of cost, which it needs to give me, which needs to help me create personalized experience for my customers. because now there's a lot of competition in the market. There are too many freight forwarders, for example, who are providing the same set of services. So the customers are spoiled for choices. So if I can't create a differentiator in their mind, I will probably not able to retain that customer. They will switch to the next competitor next door, right? So the entire business is now kind of getting ready for this adoption. And so I believe this is the right time that the technology evolution and the demand forces are coming in the right time, in the right place, which will lead to the adoption as well. So that's the why part. Now let's come into the first question, that what is intelligent automation in the first place? So as the word, as the name suggests, so it is composed of two bits. One is the intelligence, which is the ability to learn from data and take autonomous decisions, while automation is about the automating the actions, where RPA is one of the leading platforms which can help us do things, automate things across the system's boundary. But now the change is happening. The demand forces which I talked about, they are looking towards giving lesser and lesser inputs, but expecting more and more intelligent output. Now that is requiring a lot of focus on intelligence. And there is a shift happening from rule-based automation or codified automation to intelligence-based automation. So to understand that, let's understand how a traditional automation would or typically happen. So in a typical traditional way of development, we have what we call a programming interface, right? Now, a programming interface is nothing but a programming language which the machine understands, and a segment of people who can do that are the developers who does the coding. Now, an interesting fact is, I was Googling up the other day that only 0.03% of the entire world population is the coders, the people who can code, that which comes around 24 to 25 million people worldwide, which is equivalent to the population of Mumbai metropolitan. So the entire IT that we are boasting today is composed of people which can be fit into Mumbai metropolitan. And the rest of the world are all the users who are using stuff which these guys are producing. Now the need, what we are seeing now, if I understand that but we are seeing that programming interface driven development is reaching its limit. Why? Now let's understand how a developer's code. Now when they're trying to code, they create what we call a happy path. Okay, so which is the core activity which somebody has to do. For example, creating an order, generating an invoice, or taking 10 steps to the door. So they write the happy path, and then they figure out, okay, there is some variations there, some variation there, and they start adding them into their code as if and else blocks. If something is this, then do this thing. If the condition is that, do that thing, right? So they keep accommodating these variations as if and else into their code. Now you can understand, now if I have to write a program to take 10 steps to the door, there can be 100 different variables that can come in which will stop me from reaching my objective, right? Now, if I put all those, the first question is, can a developer think through all of it? The traditional way of programming demands that the developers foresee all the different variations possible and accommodate them in the code. But now with the need of lesser and lesser input and more intelligence, now the quantity of variables are kind of exploding in geometric progression. Now, if somehow somebody could even put all those variations in the piece of code, think of the complexity of the code that it goes into. Now, can I change somebody else? Can some other developer learn this, understand this code, and make changes, because change is the only constant now? Or even the person who has written it probably won't be difficulty in writing it, understanding it maybe 2 weeks back, 2 weeks after the code he has written. So the complexity of the code becoming so high to address the need that it becomes impossible to use only programming interface for the next gen solutions that we are expecting out of the IT world. So we needed a separate and additional set of interface, which is calling the human interface, where so far we have to learn the machine language to ensure machine does what we want. But now the trend is reversing. The machines are learning human language so that they could collaborate with us, they can understand our queries, and can deliver what they want. right? And to do that, to enable this human interface to work, a new science, a new separate branch of artificial intelligence is evolving, which is called the generative AI. Now, this AI not only understands and learns and take decisions, it can even create new content, right? It can create, it can write answers to our exam questions. It can compose a new poem. It can create a video. It can create a song. It can paint a picture, whatever it is. So it is able to understand the human conversations and create and generate new code, new contents. Now, to understand the human conversation, they have to do some special activity, because humans always interact, with some context, converse with some context. We can use the same word in two different places to mean two different things, right? To enable the Gen AI technologies to understand that, they have to have something which is called large language models or natural language processing, NLPs. So they have to be trained. They are currently being trained using large language models so that they can understand the context of the conversation and identify what is the core issue or core intent that the user is asking for, and then use this learned knowledge to take actions or generate codes. Now, let's take an example of a kind of a everyday example, that a person is working on a system, which is an order booking system, and it is the beginner's peak hour, and suddenly the screen got frozen. Now, naturally, the user is going to be totally frustrated, and he writes a kind of a bad mail to the support team saying that this is the issue. Work towards fixing it as quickly as possible. Now, how this intelligent automation will work in this case? So it will first trigger a RPA bot to go and read the emails that it has received and extract the content, the text out of it. It can be the attachment by using some scanning technology, or just read the content, read the content from the email and pass it into the language model for the generative AI to understand the code issue. What is the main issue that the user is trying to raise? Now, once it understands what is the code issue, which in technical terms we call it the intent, now it can put that into its artificial intelligence repository to find out whether there has been any corrective actions that has been taken to fix this issue. And if it happened to find, for example, if it's like that, if there is a service which probably got stopped for which this issue is happening, then the artificial intelligence can trigger an RPA bot, go and restart the service, which the bot does, and everything starts falling in place. And the Gen AI generates a nice little mail saying that, okay, your issue is solved. It can communicate either as a voice interface-based interfaces, or it can be chat, emails, or chatbots like ChatGPT. In case it did not find a earlier occurrence of certain fixes, it can understand, and it can run a RPA workflow to decide which person to route it, which team to do it, whether it's the internal development team or it's the infrastructure team or the security team. It will do it and tell the human that the help is underway. So, so this is how the intelligent automation is differing from traditional automation. Now, whatever I just explained so far is on a layman's basis. But since we are techies, so let me explain a little bit on this in the way that how a technology architecture will look like if we have to build an intelligent automation system. What will be the architectural topology in a quick, easy to understand way. So typically, whenever you go into any company, you will have some bedrock applications, right? You have CRM, you have order booking, you have WMS, transport management, invoicing, via analytics. So you will have bedrock applications which serves the purpose of their daily working. Now, in typical situation, you will probably have some control tower visibility systems, which has API and web service integrations across different systems to provide the information in one place, so that when a customer calls up or sends an email, there is a human in the loop who interprets it and uses these systems to provide the clarification or the fixes that is necessary. Now, in the intelligent automation world, so we will probably have in the integration layer a set of bots created in RPA, which can do specific activities within or across systems, can pull up information from invoices, or take out the shipment status, or figure out how many leaves left for an employee from the HRMS system, anything. So it can have separate different bots that we develop and keep it there. And these bots will be triggered by an intelligence that will be sitting in the command and control, which will have the NLP capability so that it can understand the human conversation. So when people, like customers, interact with the things like emails or chatbots or voice, whatever the interface are, and sends out the queries, the command control module will probably understand and figure out what is the intent. And once it identifies the intent, it can figure out which bot it can trigger to actually carry out the activity. So you see, whatever we have been discussing so far, it's not a sci-fi. We already have the technologies and the platforms in place. It's only that we have to tie them together in a particular way so that we can create this intelligence automation. So Saroj, to a very short answer to your long question was this, that this is how intelligent automation works. Back to you.
That's fine, Hitam. So understanding the concept behind, can you cite some practical example or real world scenarios where the intelligent automation really work in the place?
Yeah, I think this is the interesting bit in this discussion because whatever we do, I mean, if we query the internet or query the chatbot, I mean, ChatGPT, we get a bunch of use cases. I mean, where Gen AI and Gen AI use cases comes out. But many times, more often than not, what I've seen that those use cases are very, very high level and very difficult to comprehend the how we should go about it and how those can bring realistic values to an organization. So, so I thought of sharing few case studies, which or use cases rather, which our customers are also trying out, which can bring kind of definitive value, some realistic output. So the ROI calculations can be easier, and the value proposition is on the face. So I wanted to share a few of those use cases. So the first set of use case would be towards harnessing the cognitive ability of the intelligent automation stack. So, but first, let me talk about a few of the technologies, because in the intelligent automation space, there can be there are multifarious technologies that are available, and people can easily get pulled in all directions. So in our experience, we found out these 4 technologies can be sorted out to be used, curated for the purpose of many of the use cases. Like first is NLP, so some way to understand the human interfaces. RPA, IDP, these are like intelligent document processing engines and OCR engines that we can use. And and lying on top, there is the intelligence automation layer. So these are the 4 technologies that probably we can shortlist for our corporate POCs that we want to run. Now, the first case study that I am taking up is what we call the automated issue triage. Now, issue handling is a very downtrodden. It might seem that it's a very downtrodden use case, but it is actually very applicable. It has very high applicability when it comes to intelligent automation. Issue triage is not just for IT systems. It can be very much applicable to customer services, after sales, even employee to HR communications, right? Applications is always there. So people are using, as the people are using more and more systems, they will always have an issue to be fixed. And I only buy something when I know that the customer support is good. If something happens, if something doesn't happen, then I will always reach back to the customer support and I'll get the necessary help I need. So automation of issue triage is a very interesting and a very realistic use case that can be applied in any organization and can be tried out. And typically in this use case, you have 4 categories like collection, categorization, prioritization, and routing. So if I try to implement a kind of technical approach that I'm providing here, people can find their own approaches. But this is a typical approach that we can use. Is like first, you can see down there are like 5 boxes. They're colored differently. The color codes are actually linking to the technology stack that I have mentioned. So the first phase is automate the ticket intake. Okay, so you can write some RPA bots which can read the information from emails or ticketing systems like ServiceNow or any other ticketing system that you're using. It can extract the information, ticket information, and then can push it into the NLP layer to parse the information, to understand what is the main issue that user is trying to complain, right? So now the NLP will take over the processing. It will figure out what is the intent, and it will probably able to classify based on the training data that we have provided, that if this is the issue, then this is of this category. Category means it can be the development issue, it can be a security issue, it can be an HR issue, it can be finance team issue. So categorization of issue is very important when you are doing issue triage, and that categorization can be trained very easily into the AI systems that we can build in, so that it can automatically tag those issues and categorize them. Now, once it is categorized to a certain bucket, the next important activity is to prioritize the issue. What is the severity of this issue? Now, the severity can be, again, be processed through intelligence by finding out what class of user this person is. If they are coming from a high impact user domain, then this priority and severity is very high. What kind of business process the issue is related to? If it is a very critical issue, then again the severity goes up, right? So these different factors can be put together in the models so that the system can automatically assign a severity against the issue which has been priorly categorized. Now, once we have the categorization and prioritization done, then it can use that issue to figure out from its learned knowledge base that whether there can be any automated fixations or responses being able to be provided. Now, if it finds something, then it can use RPA obviously to get those actions done, and it can respond back with some generated interesting conversational mode contextual information, and it can send it back through any channels as chatbots or voice integrated platforms or simply emails. So these auto responses can be sent and fixations are done. In case it failed to identify any fixation, probable fixation, then it can use a workflow of an RPA to decide which team can handle it, be the dev team or the test team or the finance team or the security team. So it will route the ticket to that particular team so that the person can do that job and inform the user that something is work is under process. So this use case, if you look at this automated issue triage, now the best thing about is your organization is already having a lot of data on it. You already must be having some amount of data captured in some way, which is one of the pre-criteria for any intelligence automation, right? You have to have a good amount of data to process and train. And secondly, this is a very comprehensible use case to say. Everybody understands it, and it will be easy to calculate its ROI, and it's probably easy to adopt because this is something very core in the services industry that we are providing. So this is one use case, Saroj, that I think that we can readily use, where we can do something and check back how suitable it is for our company. The next set of use cases that I'll talk about, which will be looking after the processing automation side, the intelligent processing side of the intelligent automation. And there, one of the important category is the automated documentation, right? Now, this is the core, one of the fundamental strengths of generative AI, that it can generate code. So it can create documents, it can process documents, it can look into defects and cross verifications. So all these sorts of use cases can come underneath it to reduce the paperwork, to streamline the administrative processes, or to detect the risks preemptively and take actions proactively. So all these can come in. So case number one, the use case number one for it is document processing. Now, we all have seen that we process and consume a lot of documents when in a business environment. It can be invoices, it can be orders, it can be claims, for example, it can be customer complaints. All these documents can come in various different formats. So one use case is, can we automate that process? It can be as simple as automate the invoice processing, because we are working with one of the customers here who daily receives almost like 10,000 to 20,000 invoices every day, and coming from almost like 500 plus vendors of all different formats. humanly, it is very difficult to manage all of it. So they wanted something to test out if the advanced automations can help them to extract the information. So the process is you have to scan, classify, extract, and integrate. Scan can be done through IDP technologies, intelligent document processors, which can scan from the information that is coming as a document format, PDF, images, or otherwise. Classify them based on certain information that it is of which type of vendor, which the vendor template to apply. Once it classifies, you can extract information using the intelligence and then integrate with technologies like RPA or other automation technologies, and you can feed into the systems wherever you want to for processing the information. So this use case is another example of a use case which is practical, yet it can bring out visible values and it is easy to comprehend. Few more are like document generation, right? Where you can generate documents out of the information that is available. And one of the important steps is integrate, classify, generate, and communicate. Take an example like the pre-sales team or the sales team or the business development team. They sends out emails to different people to cold call or to get the leads generated for a company. Now, can we use this generated AI to create those personalized emails instead of sending a one template for all kind of emails? Can it do it? The answer is yes. We can actually use generative AI to generate personalized emails with certain information that I want to sell something. Can you do it for? And it can even personalize it based on the level of the recipient. If it is a CEO, then it can create a mail which is suitable for that CEO to read. If it is a operation manager, it can create and change that, which possibly normally not possible when you're dealing with human counterparts, sorry, in the sales or marketing or in the business development team, because everybody at the root level may not have the same amount of understanding to create those personalized emails. So a use case of document generation, was one. The personalized email is one. Then it can be other things like contract creation, contract document creation, bill of lading, packaging lists. So all these are the other set of variations where document generation using the generative AI and automation can be of great help. The third category of use case that I would like to focus is data verification, right? So now the cross verification is one of the important aspects. Like you are receiving invoices and you have to cross verify against the rates that you have agreed. You are receiving bank loan documents. You have to cross verify against the person's account details. So all these cases are kind of a very, very integrate use cases where intelligence and automation can work very closely to reduce the paperwork, to reduce the human effort, to reduce oversights that can happen from human mode development. Or it can also be used in error detection. Now, for example, in shipment services, what we see is that there are multiple exceptions that happens while the shipment is moving. It has to be coming on certain date. It failed and delayed by 2 days. The ordered amount was this much, but actually a less amount has been shipped. So these events, these error events that are happening. Now, if we can train a system that for a certain types of item type, for a certain type of carriers, for a certain time in the time of the year, certain type of mode of transport, can you predict what kind of exceptions might happen? So this can help actually the operations teams to proactively work towards mitigating them if they find that, okay, this kind of exceptions might happen for this shipment that I'm making. It can be freight audits where you can match against the invoiced amount against the rates that has been approved. It can be compliance checks. It can be risks and mistakes detections. So these are the areas where you can actually apply. Now, all these use cases that I've just told, now these are cases where you already have a lot of data in your organization, number one, and you can kind of easily comprehend these use cases. And these are actually use cases that so many of our customers are trying out. So I see that probably you guys who are listening can also try out some of them and see how it is benefiting, and let us know if it has worked for you. So Saroj, coming back to you, these are the different use cases that I see we can apply intelligent automation to get into the next order of human intelligence.
Thank you, Ritam. Ritam, before we move to Q&A, right, can we quickly summarize what we have looked so far? Mainly, how the industry is shaping up in terms of generative AI and RPA. Then we looked into how intelligent automation comes into picture, which combines both the capability of standard AI as well as generating AI. And we discussed some of the case studies where these technologies could be applied to get some business benefit out of it, right?
Correct.
So I think for sake of time, we should move to Q&A session. Any specific question anybody has or we want to answer?
I am seeing one question. Let me pick that. Then others, Saroj, you can also help me. One, somebody is asking about like what is the difference between AI and machine learning? Right. That's a kind of a question I would like to pick because this is something really a question many people ask. See, machine learning is one of the ways an AI learns things. So they are not same or they are not different. They are actually one is dependent on the other. AI uses machine learning as one of the means to learn information. So typically AI learns by two ways: supervised and non-supervised or unsupervised. So supervised means somebody, a human in the loop, should train the AI that this is a red circle, this is a yellow triangle. So that is supervision. So, and there is an unsupervised mode of learning also, where the system using mathematical algorithms and all, it will detect patterns in the data and it will use them to predict a future value, a future information. That is unsupervised. So machine learning comes under the unsupervised mode of a learning mechanism where it provides different algorithms, different processes, different ways, different tools to learn, to help AI learn the information, learn the intelligence, wisdom out of the data to predict information. The predictions can be who will be the next World Cup, or it can be as simple as what will be the weather tomorrow. So these prediction models which are coming, so these can be held using machine algorithm, but this is how they are differing each other. So Saroj, this was one question. Next, if you want to pick anything, you can.
Any other question?
So Saroj, I have one question. How will Gen AI and RPA together be an optimum solution for supply chain industry? So this is something specific I think we've seen, and can you throw some light on any use case on this?
See, supply chain. So I can pick this question. So supply chain industry, the use cases that I have first shown in the last slide, where the issue triage was discussed, right? So supply chain is a business of people, right? Humans are always part of the loop. You cannot actually remove that. So customer support is one of the very, very important after sales or as a service. Is a very important to create these self-service or the personalized service that you can provide to your customers. So that is certainly one use case that you can look into how to automate that. The other part is the document generation or document processing, which are like where you are actually, because in supply chain also you are dealing with multiple various partners, various partner companies, various carriers. For example, if you are a 3PL, you are receiving you are using maybe 50s and hundreds of carriers for your shipments to happen. So at the end of the day, they will send you back the invoices. How you validate those invoices against the rates that you agreed with them. So that is one area where invoice processing can certainly be. The other thing that I talked about, the exception prediction, right? So that is again a key item to take proactive actions, that how the system can predict beforehand for a particular shipment what can be the possible exceptions that might happen, be it based on the item you are picking, the type of shipment, whether FCL or LCL, which carrier is carrying, which time of the year it is happening, whether it is using air, sea, or road mode of transport. So it can be many parameters it can look into and can predict what are the possible exceptions possibility and take proactive actions towards it. So, and the other would be the bill of lading, because that is one of the most critical document in shipping world. And the problem is there is no standardization of it at this moment of time yet. But bill of lading, BOL as it called, now it is everybody creates it in their own way, right? And everybody thinks that is the correct way, right? So how do you generate as a company? How do you generate so many different forms of bill of lading if you have to deal with? So those are the areas where you can use Gen AI or intelligent automation, to be more specific, to help you in those areas. Anjan.
Thanks, Rhythm. Thank you for that. I think I don't have any further questions. Saroj, if you have any, you can go ahead.
Or no, I don't have.
All right. I think we can conclude, Rhythm, if you say so.
Yes. So I think only the two things that I would like to add, like as we have seen, the technology is evolving, and it is evolving at a breakneck pace now. Now it is moving into the phase where the next order intelligence is the call of the day, is the need of the time, and technology approaches are changing, and new ways of programming abilities are coming into play. Although the developers will remain relevant, so we should not be fearing about it, but the technology will act, or this bionic intelligence will act as a digital dual and can provide and act as a guide or a assistant to us. So this is what I want to conclude by saying this.
Absolutely. So just to add on to Rhythm and to conclude today's session, so I'm just thinking about talking about combination of Gen AI, or now as we derived in this session, we call them as intelligent automation. So I think we can definitely say that it is a powerful toolkit for automation and innovation, which also which also gives us an improved efficiency, right? And by understanding the application and benefits of each technology, businesses can strategically implement these solutions to stay competitive in the evolving landscape of artificial intelligence and automation. So the last statement I would like to make is integrating intelligent automation, businesses can achieve even greater efficiency and optimize automation. So that concludes, I think, today's session, and I thank everyone joining this session today. So we will share the content over the mail and connect with you. Thank you, everyone.
Thank you.